This conference will now be recorded.
Excuse me.
There we go. It's located between mileposts 264 and 267.5. For those of you that are kind of familiar with the area, as you're driving from Albuquerque and you're heading north, you work your way to what is the Bajada interchange, and you start going up what is a pretty steep hill, La Bajada Hill. And this project basically is in that particular area. It goes all the way up to the top of the hill and ends over there at the Waldo interchange at the top. The work that we're going to be doing is mainly focused on the first bulleted item there. It's geotechnical mitigation and slope mitigation. So they have some problems down underneath the pavement, and our guys with Golder are going to describe what that problem is, and we're going to go ahead and try to fix it so you don't get that roller coaster effect that you're seeing when you're driving up and down that road right now. As part of that work, once we're doing the work underneath it, we are going to rebuild the roadway as well. So the pavement is going to be reconstructed and worked on as well. And since we're in the area, we're going to look at improving and replacing the drainage structures that are underneath the roadway. We're also going to look at implementing safety improvements to the project. So the safety improvements would help improve your driving experience and hopefully prevent any future accidents from happening. And last but not least, we are going to be putting some intelligent transportation system, ITS, improvements in the corridor. And we have a slide that describes that as well. Next slide. So here is the project limits that I kind of discussed in a map. So you can see down at the bottom left of the map is the milepost 264. That's the Bajada interchange. And you work your way up that hill and over to exit 267 Waldo interchange. So it's a short project, only like 3.5 miles. And actually the bulk of the work on the interstate is going to be around the Bajada interchange and as you go up the hill. For those of you that are familiar with the work that was being done out there earlier in the year, they did some mill and overlay projects, and they stopped the pavement mill and overlay project at 2 specific locations. So we're basically going to be filling in the gap there with that project. Next slide. So the schedule for our work. Right now we're in the design phase. And so we've been working on it for a little while now, and we've put together 30% plans back in July. We're currently at the public meeting number 1, so that's what you're attending today. So that's our second bullet. We are working on 60% plans and finishing up the geotechnical report, and that should be completed by October next month. We'll work ourselves into 90% plans in December, and hopefully all goes well, and we'll be finishing up our plans in February of next year. The construction of the project is going to be pending some additional funding. At this time, the state does not have the full funding amount that we've anticipated. But right now, you probably won't see the construction happening next year, but you would potentially see it happening in the fall of 2022. Now that may change if money gets shifted a different direction, but I'm not going to speculate at this time. So for now, we're going to tell you fall 2022 for your funding and your construction. Next slide. Here is your cost amounts. So right now, our engineer's estimate has anticipated this work to be almost $41 million. It seems like a lot, but when you see what Michael's going to explain to you later on, you're going to see why it costs a lot, because we're going to do a lot of work underneath the roadway itself. So it's $41 million in an estimated project. Current funding is only $18 million. So the DOT, the district, they're going to look to secure that remaining funding, as I discussed earlier. Next slide. Existing conditions. So as part of our study, we want to document and explain what the existing conditions are out in the corridor. So next slide. So as you go up the hill from the Cochiti interchange, this is kind of the typical, what we call the typical section of the roadway. As you're driving up, heading northbound, you have 3 driving lanes. One of them on the right there is considered a climbing lane for the trucks. In the southbound direction, you only have 2 driving lanes, and you have a what is called a pressed median in the middle. And at one point in time, a couple years ago, they installed a cable barrier in the median as well to help prevent traffic from crossing over and running into the other side. Next slide. So one of the safety improvements we're looking at deals with these ramps. So if you're familiar with the way these interchanges, the older interchanges work, they have what they call our taper type ramps, where it's basically you're entering and exiting off the interstate main line rather quickly. So you got a very short period of room, or a short distance to make your way into the main line of the interstate. So those are some of the issues that we want to deal with as part of our safety improvements in fixing these taper type ramps. The ramps were considered sufficient back in the day when they were being installed, but as traffic gets a lot faster and vehicles get a lot faster, they become a lot more difficult for people to enter into the main line. Next slide. And here's some pictures of the existing conditions out there. I know you're driving down it pretty fast, so you don't really see it, but when you're driving down in the southbound direction, that picture on the left has what's the guardrail. Well, we've got a lot of issues with debris catching behind the guardrail and getting stuck over there, and the drainage on the roadway gets stuck and floods and creates issues with erosion. You could see that in some of the other pictures on the far right and around what is considered that run down there. So we're going to try to fix what are surface flow erosion issues that are happening out there, and try to make all the water flow properly. A lot of what we call the rundowns is that concrete there. Those items they were built and a lot of them have failed over time. So we're going to be replacing the ones that are failed and try to improve on those. Next slide. I'm going to hand it over to Michael here to talk about the geotechnical issues and with regards to the pavement. Michael, it's yours.
All right, thanks, Derek. Just make sure you can hear me all right.
Yes.
Do you want to get it and you listen to your thing?
All right. So yeah, I'm Mike Pegnam with Golder Associates. We're doing the geotechnical work on the project, and these photographs kind of show an up-close view of some of the pavement cracking that's exhibited on the project. On the left, you can see a crack that's actually extending transversely across the travel lanes, causing a bump in the pavement. And there's some more severe cracking, like you can see on this photograph on the right, where you actually have a crack that has down dropped, so just a bit, so that the shoulder is a little bit lower than the pavement, closer to the lane. So obviously, if a crack like that was able to shift into the travel lane, that would cause an additional bump for present a hazard to drivers. Next slide. In some areas, though, the cracking is not very severe, and yet there's still some lane settlement. So you get those sags, and like Derek mentioned, that kind of roller coaster ride. So that's like the photograph on the left. In some areas, the deterioration is not even visible from the roadway. The photo on the right is a good example of a culvert outlet where you've got severe erosion occurring at the bottom of the southbound embankment, and obviously that could be a situation where the erosion could continue up to the pavement. Next slide. So in order to figure out the best way to repair the situation, you actually have to kind of look all the way back to the history of the alignment. The original 4-lane divided highway was constructed in the early 1950s by widening what was an existing 2-lane route that was built in 1931. Next slide. In the early 80s, the route was widened again to add a northbound travel lane. And as part of that widening, it appears that there was at least 2 major material types that were placed to construct the new embankment. The purple color here that's labeled rough grade fill makes up most of the lower embankment. The green colored capping fill is the part that's just below and supporting the pavement structural section. Next slide. So when the material is placed, whether it was poor quality or it's just degraded over time, it's started to settle, and most of the settlement is concentrated in that lower part of the fill, although there is some contribution to the settlement from the upper fill. And this is basically, the settlement is the main thing that's causing the edge cracking that's been observed and experienced by drivers. Next slide. So this image is actually an aerial photograph from the original construction in the 1950s widening. And so the reddish color fill that you can see here, that's the material that appears to have been borrowed from the construction that was taking place at the time for the interchange at exit 264. This material is actually a mixture of both sandstone and which is a very durable material, but also mudstone, which is mostly clay. And that's moisture sensitive, and it can become weak over time. Next slide. So when we investigated this, we can actually measure the compaction of the embankment with an instrument that's called a penetrometer. And the graph on the left is the results of one of these tests. And this particular test was taken in one of the areas where the shoulder cracking is most severe. The blue arrow at the top is kind of like our cutoff of what we would typically like to see to indicate good compaction. Next slide. But I've highlighted here the portions that are less than 50 to highlight the areas that are soft. And so what we can actually see is that above 10 feet, which is in the zone of the capping fill, we see some thin layers that aren't quite well compacted. But when you get below to more, where that sandstone and mudstone mixes, the poorly compacted layers become much thicker. And this is a pattern that we see throughout the area when, pretty much wherever we do this test. And again, there are deficiencies in the drainage conditions themselves, which helps to accelerate the deterioration. Although the culverts meet drainage capacity, the rundowns and the outlets of the culverts are badly eroded. And also some of the culverts, they actually leak into the embankment material itself, which can further soften and weaken that kind of vulnerable clay material. Next slide. I think it goes back to you, Derek.
Yes, thank you, Michael. Proposed conditions. So we're going to try to explain how we're going to do our best to repair and reconstruct the project to alleviate these issues that we've noted. Next slide. So the roadway itself is not going to change much so far as vertically. It's not going to change horizontally that much, but we are going to do some work on it. It is going to get a brand new pavement all the way across. What we are going to do, since there are 3 driving lanes in the northbound direction, and there is a potential for 3 driving lanes on I-25 in the future. I'm not going to say when, but we want to take care of addressing a future southbound driving lane, a 3rd driving lane over this area, so it does not have to be completed whenever that project comes through. So you're going to see us build in that future driving lane. It won't be able to be used at this time until that future project comes in and ties into this section. What I showed you before was a depressed median. We're no longer going to have a depressed median in the middle. We're going to fill it in and pave over the top of it and put in what is called a concrete wall barrier. and it's going to be right in the middle. It's similar to what you'd see as you're driving down from Bernalillo heading into Albuquerque. It looks just like that section. So that'll get replaced in the median there. And then, of course, with all the construction being done, we will replace the deficient and damaged metal barrier over there on the southbound lanes, and that'll be brand new wall barrier or metal barrier as well. Next slide. To work on what I was talking about, those taper style ramps, and make those a little safer, what the new design practice is to put in what we call acceleration and deceleration lanes. So we're going to be extending those ramps on the Cochiti interchange at the bottom of the hill there. And so we're going to be providing additional pavement and pavement widening so that people can get on and off the interstate and have a little more room to either accelerate or decelerate depending on which direction they're going. So what you see on the slide there is an example. The darker gray area is what would be added pavement to the area. Next slide. And the ITS is what I was saying before. The ITS that's going to be implemented, this is the Waldo interchange up at the top of the hill. The state has been collecting data on weather. It's called a road weather information system. So they're going to be placing this in the middle of the interchange, and it's going to assist the New Mexico DOT in collecting weather data up at the top of the hill. And that data is going to be available to their staff, their maintenance staff, and it's going to correlate into data that's put onto the New Mexico Roads website. So when you're looking to see what road conditions are going to be like, this collection system is going to help provide information for that. Next slide. And I'll hand it back over to Michael to talk about the geotechnical.
All right. So we looked at lots of ways to mitigate these problem areas. Obviously the easiest one to do would just be to excavate out the poor material and replace it with better material. But as I showed in my previous slide, unfortunately, some of these areas, or the problem areas, are quite deep in the fill, and so that presents some challenges. So the repair has to basically address the deep settlement of the fill, and also stabilize these areas where we have cracking that's occurring along the edge of the embankment. So the selected option that's shown here is basically, it's a two-component system. It includes what's called an engineered load transfer platform that's supported, as you can see in the diagram here, on columns of soil cement that essentially bypass those weaker layers. So next slide. So this photograph here shows a rig that's typically used to construct these soil mix columns. And there's a video that'll play here that shows the process. Basically, these paddles mix into the soil, and they add water and cement to the soil, and that creates a column of what's called soilcrete, which is stronger and stiffer than the soil that's been replaced. And these columns can be constructed in a grid pattern over the alignment area. And next slide. And these columns are going to support a load transfer platform, which is basically the structure that will support the pavement structural section. One of the alternatives, which is shown in the video here, to construct this load transfer platform would basically be to mass mix the soil using the same soil or the same cement and water additives that are used to construct the columns themselves. And this could actually be done to a depth, that of approximately 10 feet, which essentially would treat the thickness of that upper capping fill that I mentioned earlier. The second option would be to construct the platform from a durable fill material that's reinforced with several layers of geogrids. Geogrids are basically a strong plastic, like you can see in the photograph on the left, that's fashioned into a grid. It has a lot of tensile strength that helps distribute the traffic loads directly to the columns. Next slide. And this is a photograph of one of the geogrid layers that's just been placed on a lift of that select fill material. So these get placed in sequence. You put a geogrid layer down and put a lift of durable fill over it, and followed by another geogrid layer, and repeat that process. And once several layers of the geogrid have been placed, that platform, which is supported on those columns again, that's where we would reconstruct the pavement structural section.
So I think that's my point there. Thank you, Michael.
Sure.
Drainage improvements, as Michael had mentioned, we have a lot of erosion happening out there. So we're going to be replacing these concrete rundowns. A lot of them were placed with what is called a riprap, and we're going to make them solid concrete so they have less chance of eroding, and it helps carry the water down the slope. We're going to most likely be replacing or repairing and lining the existing pipes that are crossing underneath the roadway. They are very deep, so it is going to be a very difficult construction method to try to get them completely replaced. If they are completely replaced, we're either going to have to trench down there to get them, or what they do is bore. They call it a boring process, where they push the pipe through underneath the road. In an effort to try to capture some of these flows, if you're familiar with the area, you can see that there's some actual water seepage flows that are happening in the area. So we're going to install a storm drain pipe system in the northbound ditch line, and we're going to try to capture some of these seepage flows and prevent them from getting underneath the roadway embankment. They'll capture in what is a perforated pipe, surrounded by a lot of gravel, and it'll get caught in there, and it'll get dumped down at the bottom of the hill. Next slide. And we'll turn it over back to Eric to talk about the environmental process.
Thank you, Derek. Next slide, please. We're doing environmental studies as part of this project. We're covered at the federal level under the National Environmental Policy Act. We're covered federally because the Federal Highway Administration is involved in the project. The National Environmental Policy Act, or NEPA, requires us to look at existing conditions in the environment, develop a purpose and need statement, compare alternatives, including a no-build alternative, and develop mitigation measures. Parallel to that is the New Mexico Department of Transportation location study procedures, and this also requires us to look at alternative and spells out more details in doing studies and selecting a preferred alternative. As part of the environmental process, we have agency consultation going on with agencies such as the State Historic Preservation Officer on cultural resources and other issues if they present themselves. Public involvement is a key part of the process, and that's why we want your comments here on the project when you have a chance. We are actively working with stakeholders such as Kewa Pueblo. Next slide. The physical environment we're looking at, especially geology, soils, and water, and that's kind of some of the issues on this project area. Under I-25, a lot of the material is fill, geologic, and soil material, and the drainage and the mixture of the three creates problems of subsidence and some erosion. So that's a big part of what the project addresses. Most of the geology and soils are fill material, though if you get out a little further, you do get the natural soils. Water, there are a couple of ephemeral drainages, and there is a wetland way at the south end of the project area. Air quality is quite good in this area. It's an open area and gets open breezes, and that tends to keep the air quality good, as well as there aren't many emission sources beyond the cars on I-25. Next slide. In the biological environment, we look at various things. Vegetation, it's mainly a juniper savanna vegetation, but it does get into coniferous woodlands and plains grasslands. We do inventory noxious weeds, and if there are critical noxious weeds, we would look at doing some control measures. Wildlife, there is a fair amount of wildlife of birds, mammals, and little reptiles or lizards in the area. More than 20 migratory bird species were found, including these Say's phoebe that are on the picture there. Threatened endangered species, we really haven't seen any in this area. We did special surveys for the state endangered gray vireo, but none were located. Next slide. Cultural resources throughout New Mexico is always a big issue. The state has been inhabited for thousands of years, so there is a chance of encountering archaeological sites and historic properties. There are a few archaeological sites, but they tend to be a little bit away from the roadway prism, out in areas where we don't have fill material. We also are interested in traditional cultural properties, so we are consulting with tribes that currently live in the area, as well as tribes with historic affiliation to the area. Next slide. The human environment is of most interest to people. Right along this segment of I-25, there aren't any residences or commercial establishments located adjacent to I-25, though within a few miles there are residences and some businesses. Socioeconomics, I-25 is a key economic role as the main artery between Santa Fe and Albuquerque, and with daily traffic, and it's really critical that this road is open and maintains a good flow so people can participate in their daily commutes. Visual resources, the views out here are fairly good. You can see up to 60 miles away, up to the Jemez Mountains or out west to Mount Taylor. So the views are really good, and we don't expect to be changing that. As part of our investigations, we do check for hazardous materials to see if there are any old filling stations in the area or other sources of contaminants. And next slide. And so this is our project team. And I'll switch it over to just give the New Mexico DOT district engineer a few minutes to talk here about their role in the project. So Paul, do you want to take it away?
Certainly. Thank you, Eric. Derek, thank everybody for joining us, DOT staff and all the visitors who shall remain faceless on the screen. I think it's only like 4 or 5 of us that are daring enough to show ourselves, and I count for 2. Thank you for your presentation tonight. Interstate 25 issue with La Bajada Hill slipping down a side slope has been going on for a number of years. It may have started or first become noticeable in something like 2005, 2000, maybe even in the 90s, but it'd been monitored for a number of years by DOT, enough where just a few years ago, vertical and the horizontal displacement of the shoulder there on the southbound was severe enough where the shoulder had to be closed, and we put that wall barrier up there to deny use of the shoulder here because it's really a vertical exaggeration. It's something that because New Mexico DOT is the keeper of the interstates, federal highways. The interstates in our district, I-25 and I-40, are our priorities. This, of course, is therefore a priority. Unfortunately, it's not adequately funded, and we're always looking for money to get it funded. I think Derek mentioned looking like fall of 22. If we can get this designed and ready, we may come into some other funding, maybe some federal redistribution monies that we can get so we can advance the construction on this. And it is a priority for us. As I think Eric mentioned, this is the only way to get from Albuquerque to Santa Fe really reasonably. It carries a tremendous amount of traffic in the morning and in the afternoon, and it's including heavy truck traffic, and people need to get through with as least disruption as they can. It's on a steep slope. I don't think I heard much conversation about the slope, but I think aren't we on like 8% or something like that throughout some of this, and which invites other challenges with snow removal and the effects of climbing up the hill with snowpack and icy conditions on it. I'll mention one other thing about the cross section. One thing about the cross section here, we're adding a lane, which is a good idea because eventually there will probably be 3 lanes between Albuquerque and Santa Fe, between Bernalillo and Santa Fe anyway, because I think there were something like 11 structures or something that would be in the way, but a 3rd lane might be able to fit under most of those structures. So it's not far-fetched to think that we could have a 3rd lane between Albuquerque and Santa Fe. So we're thinking ahead, which is great. But what we have right now in the cross section is we got that wall barrier out there. I will tell you that practically once a week somebody particularly northbound, takes that wall barrier out. I mean, wall barrier, posted cable. I'm sorry, posted cable. They take that posted cable out, and I think what's happening is, particularly in the morning, they're driving up the hill just as the sun is rising right over the top of La Bajada. They can't see, and the little rear end collisions, and avoiding rear end collisions, they go off the road into the posted cable. But we'll have not as much southbound, but this should be a safer route. There are, if you've driven up the road, you've noticed there's some sags in it, which have become in a couple of places, particularly northbound, which have really gotten exaggerated. They seem to be settling over the last probably 4 or 5 years, and every year it seems to get a little bit stiffer. Can I, if you don't mind, Eric or Michael, can I ask you a question? Are you open for a question, Mike?
Sure.
Is the rate of that roadway slipping away, is that accelerating, or does it seem to have, is it a constant rate, or seem to have stopped, or is it self-aggravating?
We haven't, we've monitored the displacement with inclinometers, and we've never detected any acceleration. So it seems to just be a constant creep.
Okay.
So, yeah.
But it's in motion.
Yes.
That's the main thing. Derek, did you estimate and maybe not this far into it yet, but did you estimate the construction time? How long it would take to build this?
Yeah, Paul. We did a little bit of an estimate just this week, and I think if you had really good weather, you might be able to finish it in 2 construction seasons. But based on the location and the fact that it does get some significant weather, it's anticipated that it may take roughly 3 construction seasons, from the spring to the fall, to finish the job.
Okay. Well, I'll assure the public, because I know our DOT staff realizes this already, and you as our partners consulting in this realize that our priorities are safety, economy, mobility, and environmental stewardship. So we're going to build it so that whatever traffic detour, whatever disruption to traffic that we have is safe and hopefully economical and with sensitivity to mobility. Those people can still get through it during construction. This is a pretty lengthy, detailed project. But I'll assure everybody that we'll do everything we can to keep the road open and flowing smoothly as we possibly can during construction. I guess I'd like to thank you for your presentation. At this point, I might invite anybody else from our DOT, if anybody's got any comments, they'd like to hear it. But other than that, I guess we'd be open for questions if there are no comments from anybody else.
Paul, could I quickly add on to your comments about keeping the traffic open?
Please do.
Right now, the phasing that we're anticipating on implementing, we're going to do it in roughly 4 phases, and we're going to do our best to make sure that there are 2 lanes open in each direction at all times. We are going to have to build some temporary detour widening in the northbound lanes to make that work. So that would be the first phase of construction. And then once we get the temporary widening built, we're going to look at putting all the traffic in the northbound lanes and close off the southbound direction for the contractor to work on that side. And then once that side's finished, we would just do a flip-flop of the traffic and the work. And hopefully that doesn't disrupt anything too bad. So we won't be shutting anything down to a 1-lane scenario that creates a lot of logjam and backup.
Good, thanks. That's the kind of emphasis I was talking about. It's reassuring that, we're working on that, and that's what we're going to do. It stays open. Anything else?
Okay, well, thank you. Can we have the next slide up, please? Next one. This is just where you can provide comments. We'll receive spoken comments right now, but you can also send written comments to me. Here's my address, and also by email, eric.johnson@nv5.com. We'd like to get the comments by October 7th. That's in a couple of weeks. That'll help us just prepare a meeting summary and move on with the project. So I'll open the floor to comments. And there's also a chat box available. Just please say your name prior to making a comment, and we'll try to answer any questions. So I open the floor up. Anybody out there? I know we have Santo Domingo Pueblo and people from the Cochiti Lake residents. So I don't know if either one of you groups want to make any comments.
This is Angie Smangla from Cochiti Lake.
Yes,
and
go
I
ahead.
want to thank you for the presentation. And I will share with Cochiti Lake residents that the presentation is out there because we will be very interested in the project as it proceeds, because it will affect us probably a lot.
Okay, we'll
Thank you.
work to keep you informed. Yes, and go ahead and feel free to provide written comments. Encourage others in your community to provide written comments. So, okay, any other
Thank you,
comments?
sir.
Sure, thank you. Any comments? We have other people on. Santo Domingo Pueblo.
Christopher Chavez from Santo Domingo. I'm the Tribal Historical Preservation Officer, and Malcolm Neto is my co-worker. We'd like to find or see and make sure there are no archaeological significance in the area. And if you can, send us some information when we can do some exploration in the area, so that we make it sure that NEPA and NAGPRA doesn't coincide with your project. And we know that it's important to stabilize that earth because it's always moving. You can see it if you drive up to Santa Fe. We're coming down from Santa Fe. So you have a lot of small hills right on the road. And we don't like to see that because Santo Domingo is in the middle of the reservation project. And if something happens, God forbid it, that an accident occurs, who's going to be blamed for it? You know, that's the legal perspective that I'm looking at, archaeologically, legal, and Santo Domingo's involvement in it. So if you can, please keep us informed as to your program or your project going on. Thank you.
Yeah, and Jennifer Mullins, who is the environmental coordinator on the project for New Mexico Department of Transportation, says we should be sending a draft report out to you in about a week. Our cultural resource coordinator has reached out to your office and they would like to schedule a meeting soon. So we have more coordination coming with the Santo Domingo Pueblo, definitely. So thanks so much for being on this meeting. Glad we're able to do some good coordination. Anybody else? Any comments? Okay, well, this is, feel free to go ahead and send us written comments. We do appreciate those. Any suggestions you have, especially people who live right near the area, probably have more insight what's going on than the rest of us. So we sure would like to get your comments. So.
Eric, real quick, you mentioned that the presentation will be on the NMDOT website. Is that, I apologize, I don't know the exact location. Is there directions that people would need to know how to find that presentation once they get onto the website?
Yeah, there's a section of the website that's districts. I'll see if I can pull, see if I can take control of the computer here and I can maybe get the address up on the screen here.
I'm sorry to hit you up with that. I just kind of thought of that. And Jennifer sent me I don't know if that's the same link.
Yeah, Audra, can you give me control of the screen here? Yeah, I think I can got it. Okay, I got it. Let me see if I can get,
Hi, Eric. This is Jennifer Mullins with the NMDOT.
yeah.
I don't know if you can hear me well enough, but I think if most people Googled NMDOT projects, they could probably find it fairly easily. I did send you the URL from the actual internet website, but it's a long one. I wish I could remember the short version, but
Yeah, I'm gonna bring up the notice here if I can, and I think we have it on there. If you go to this area right here, can you see my screen? It's dotstate.nm.us/NMDOT projects, and should be under there under the District 5 projects. And if you can't find it, send me an email, eric.johnsonnv5. It'll probably take us a few days to get it on, get the presentation onto the website. It is an MP3 file, so it's a big file, so we can't just send it in an email, but we'll try to get that uploaded. It's usually ready in about an hour after the presentation, then I can get it out.
Thank you, Eric.
So any other questions or comments?
Thank you, Derek. Thank you, Eric. Thank you, Michael. Yeah, thanks to all my DOT colleagues for joining us and the public for participating in this. One thing, when is the next public meeting like this?
I don't think it's been scheduled yet.
Haven't scheduled yet? Okay. 60% is October and 90% December. Okay.
But we'll
But
work.
it'll be made local. It'll be made known.
Yeah, we'll definitely notify people. And if you're on the call tonight and want to make sure you're on our mailing list, it's probably a good idea to send me an email, eric.johnson@nb5.com, at the email that's right up here. So eric.johnsson@n as in Nancy, V as in Victor, 5.com. And I'll make sure you get on our mailing list. So
if there is, in the event, and I'm not sure there is, but if there is another meeting, then the word will get out the same way. But we really would like comments from everybody that's on right now, because this is the direction we're headed with this project. Thank you.
Okay, well, thank you. If there are no other comments, I'll go ahead and end the meeting. Thanks again for attending. Have a good rest of your evening and a safe weekend. Thank you.
Thank you, Eric.
Thanks, Derek.
Have a good night.
Good.
Bye.